Bismillah. So I'm gonna talk about neutrophil arrival and function. Neutrophil arrival and function is basically the hallmark of your acute inflammatory process. So there are multiple steps to this, and I've written them in my bad handwriting in here. So you've got margination. Margination is basically having the neutrophils aligned at the periphery of the post-capillary venule, basically at the blood vessel. Doesn't matter where it is, but at the blood vessel they marginate, so they are on the periphery of the blood vessel rather than flowing in the middle of it. Rolling is that they are there, but they are rolling. Easy. Adhesion, they are at the same place, but they adhered now. And transmigration, they are entering and going towards the the cell that has sent the chemotaxic agents. Okay, so it's going towards that direction. And your phagocytosis, it eats whatever is bothering this cell, and destruction, it destroys it after it's eaten inside of it. And resolution is where the neutrophil says that I've resolved the problem and now I commit suicide. For some reason, I don't know why that happens. Okay. Okay, so here you've got your neutrophil. It's flowing the blood, and it's detected that there are chemoattractants. What chemoattractants do we have? We have so many. Of them is tumor necrosis factor alpha. Just remembering tumor necrosis factor helps. Tumor necrosis factor, there is interleukin 1. I don't like interleukin 6. Interleukin 1 and tumor necrosis factor are very helpful to remember because they have so many associations. They have association with fever, and they recruit the neutrophils. All right. And they also recruit your selectins and ICAMs. So they recruit them, and the neutrophils are like, okay, so we are needed here, so we come on the peripheral side of the blood vessels. So they do not flow like the red blood cells and everything. Imagine that this is your capillary and this is the end of your capillary, so it's called the post-capillary venule. So the neutrophil, what does it do? It has this area of it called SLEX, and it's a very strange name. It's sialyl Louis X. It's just a molecule on the neutrophil that just attaches to your selectins, your P-selectin and E-selectin. One of these selectins is recruited by the tumor necrosis factor and the interleukin 1. As we've mentioned, they are the chemotaxic agents, and they are really good. There are so many other chemotaxic agents as well. We're gonna talk about them if they come across us. So P-selectin and E-selectin. One of the other selectins is actually stimulated by histamine, probably by mast cells because they are acute inflammatory cells. Okay, so they go on the selectins. They are not adhered yet because selectins basically make the neutrophil roll and roll and roll, and it just keeps going on the periphery of the blood vessel until we have our ICAMs and PCAMs and VCAMs. So ICAM and VCAM. And we've mentioned again tumor necrosis factor as well as interleukin 1. These both are very important to recruit these cellular Okay, adhesion molecules. Okay, well, this is the worst handwriting ever, huh? Cellular adhesion molecules, I and V. Now they are attached, and now they are ready to go inside. Probably mixed this up so badly. Okay, these are still your selectins, it's still rolling on them, and this is your VCAM and ICAM. And tumor necrosis factor as well as interleukin 1. They are the ones that recruit these on the endothelial cell again. So selectins and ICAMs and VCAMs are all on the endothelial cell. Now here is just the complement 5A and interleukin 8, and as well as interleukin 6. You can think about other chemotaxic agents for neutrophils, but the list goes on. It's really difficult. If you want to remember C5A, it's really nice. It's a complement that helps it. And C5A also has other functions. In any case, yeah, so C5A and C3A, they recruit the histamines that put one of the other selectins in there. So what happens after? So we have adhesion. What happens after? What's our steps? So we finished margination, rolling, adhesion. Now transmigration and chemotaxis. Chemotaxis is going towards the cell that's calling out for the neutrophil. Transmigration is basically entering into the interstitium, so the area between the cells and the vessels. And then we have phagocytosis, destruction, and resolution. So we'll see. Diapedesis is the way that the neutrophils put their feet inside with the help of, the histamine causing the contraction of the endothelial cells and opening up between the endothelial cells a space that diapedesis can occur in. And that's transmigration. Then the neutrophil finds in the interstitium the area wherever that cell is calling out for it. And it just immediately comes and causes phagocytosis. How does it do that? It has these special areas called pseudopods, and these pseudopods have phagolysosomes, which are an amazing structure that has oxygen-dependent killing via many things, okay? Via reactive oxygen species. We'll talk about them. Now, before we talk about them, there are two things that help us mark these microbes. One of them is C3b. I like to think about this one as the last smooch to the microbe, the B, big smooch, yeah, and the 3. And another one is an opsonin. So this one is an opsonin, and another opsonin is IgG. Okay, so IgG. It's an antibody, but it just attaches there. Okay, so opsonins. So opsonins are markers to give the area of which the phagocytes can actually know what to eat. So basically the spice for the phagocytes. If you do not put this salt, you will not induce the phagocytosis. Okay, so phagolysosomes, what do they contain? Your phagolysosomes, they have special areas. So phagolysosome, they have a special area inside of them containing oxygen that goes into making superoxide. Okay, this is superoxide. Now we have reactive oxygen species. Okay, reactive oxygen species. An ADPH oxidase turns oxygen into superoxide, so it gives it a charge, just gives it an electron, an ADPH. If you don't want to remember these, I don't know, they're just interesting to me. I don't think I'll remember them as well. Superoxide dismutase turns superoxide into your hydrogen peroxide. Okay, I don't know about the spelling, but hydrogen peroxide is the thing that people like to put on their teeth to actually whiten them. Okay, and of course the next one is bleach. This one is bleach, and you don't want to put this on your teeth, of course, even though it might actually whiten them, but I don't think it's a good idea. So these are all reactive oxygen species. If you want to remember these as a smaller name, you have MPO, and this one can be called SOD. And this one is NADPH oxidase. I don't know how you can put this one in an acronym. Maybe you can say NO, SOD, MPO. This one, myeloperoxidase, is a nice one to remember as well because it's a enzyme that works in the myeloid progenation. I mean, myeloid proliferation in the bone marrow to differentiate your cells and make specifically your basophils, neutrophils, and macrophages, monocytes, stuff like that. In any case, you have your reactive oxygen species, superoxide, hydrogen peroxide, bleach, or Hokel, whatever you want to call it. And so they kill inside of the cell. They kill this microbe and eat it up, and they produce cytokines again to recruit more cells. And once the stimulus is done, then the cell undergoes apoptosis. The neutrophils, they live up to 6 hours, okay, probably 6 hours, probably a little bit more. They only cause 2 days to 3 days. I think 2 days is more accurate, but it doesn't really matter. It's just a couple of days that they work. And after that, they recruit the chronic inflammation. If everything resolves in 24 hours, if the stimulus is over, after 24 hours, your neutrophils have all gone and done apoptosis. And apoptosis has a mechanism as well and everything. Hopefully this was helpful for anybody. And yeah, so these are the steps. This helps me to remember. Thank you.